I would say we start. The first keynote will be Ora. I'm not completely sure when if I realized who Ora is when he contacted me. Olaf Hartig contacted me one day and said, hey, do you want to co-chair the RDF Star working group with Ora? And I think, Ora, I'm really sorry to say that, but it took me a while to realize that you were actually the co-author of the Semantic Web paper in 2000, what was it,
2001.
2001, okay. So he wrote that with Tim and Mr. Lordship.
Jim Handler.
Jim Handler, exactly.
Yeah. It was around the time when electricity was invented. It was a very long time ago.
So yeah, Ora will set the stage. He has a lot of war stories to tell, and I'm looking forward to his keynote. Thank you very much, and enjoy the day.
Thanks, Adrian. Thanks for inviting me. I have almost dried up from the rain already. I grabbed an umbrella when I left home that was too small. It's probably belonged to my daughters when they were young, but at least it had pretty flowers, so not all bad. Okay, so I've sort of come to the point in my career where when people ask me to talk, it's always like a retrospective now. So I've done all kinds of things. I was kind of in the wrong room at the wrong time, and that's why I ended up kind of doing RDF very early on, and then the Semantic Web Vision. I've done a few other things, and now I'm, like Adrian said, co-chairing the RDF Star working group. And despite the rumors, we are making progress. So I think it's all good. The Semantic Web is about AI, so I need to say a few words about my own background. My entire professional career has kind of been spent with AI, and when I say AI, I really mean symbolic AI. It was a long time ago. I was the founding member of the Finnish AI Society. I did a lot of like planning agents, all using ontologies, and wrote a master's thesis on frame-based representation. And the work I did for that actually flew on one of the NASA probes in the 90s. So that was like knowledge representation in space. And so then some 25 or a little more, 25 years ago, I got involved with W3C, and that led to RDF and Semantic Web Vision. And then I subsequently finished my PhD. And now I'm at Amazon. I'm a member of the Neptune graph database team, and so my work is now, I spend time talking about knowledge graphs and graph databases and kind of helping people make sense of it. And more recently, sort of worrying about this kind of alignment between RDF and labeled property graphs. So here's my outline. I'll talk about some old stuff, and then I'll talk about some new stuff, and I'll try to talk about a little about the future. But here's a quote that my dad always liked. He would say that very often. So I'm not going to be making any kind of dramatic predictions about the future. But anyway. So some of you have seen this picture. Graphs and ontologies, they are not a new thing. You can go way back, and it's been a kind of an interesting history. So now we've come to this, and this is really what I will talk about. And I think the arrow in this diagram is like the truly interesting part, in my mind anyway. So the old Semantic Web, the original vision. So to explain that, I have to go back to some kind of prehistorical things. So the fateful event was in '96 when I was at MIT. Tim Berners-Lee came into my office and basically asked me, what is wrong with the web? Can you imagine? And so I said, I want to build agents, autonomous agents that go out there and do stuff on my behalf, but I can't. And he got very excited and said, yep, that's it. That is what's wrong with the web. And how do we fix that? And so we decided to try ontologies and knowledge representation. Basically, I've been doing that ever since. So 1999, we had the original RDF specification. And then Tim and Jim Handler and I, we wrote down kind of our sort of view of the future, what this whole semantic web might look like, and published that. And that was a very interesting experience because there were a bunch of people who got very excited. And then there was this other group of people who basically told us that we are science fiction authors and that or that we don't know what we're talking about. But here we are, almost 25 years later. So the early 2000s, DARPA, the United States Department of Defense, basically funded a big program on the semantic web, and that gave us OWL, for example. There was a whole sort of proliferation of semantic web specification so that we got the semantic web stack. And so if we think about the world before semantic web and then what the semantic web vision was about, so this is kind of what it looks like. So content in the old world was basically, it was a web of documents. It's semantics all implicit or hidden or whatever. And we wanted kind of a transition to a web of data where the semantics would be accessible and explicit. And we would add the agents as the actors to this thing. And more broadly, standards, RDF represents kind of a different take on standardization than what we had before. So standards historically are you anticipate everything about the future and then you nail that down. And that goes over real well sometimes. So RDF is not like that. And then, of course, for knowledge representation, this is not a new thing, and that did not come about with the semantic web, but everything was kind of centralized before, and now we anticipated that maybe we could have decentralized knowledge representation as well. Now, what's really important to understand is that the semantic web is despite what people said back then, it is not a vision for some kind of a new web. It's not even knowledge representation for the web. What it really is, it's knowledge representation built using web technologies. And why is that? So people tend to forget or just weren't around back in the 90s when web came about, and it was amazing because earlier when you wanted to have two computers talk to one another, it was like a real challenge, and all of a sudden it was easy, and HTTP goes through firewalls, and so we felt, okay, now we can start building agents and distributed agents that go about and all that. And then, of course, web has this whole mindset of sharing information, which is something we wanted. And so the standardization, like I said, RDF is kind of different. We basically specified how to say things, not what to say. And then this thing here that RDF for the semantic web stack is really a solution for those use cases that you haven't yet articulated. I say that very seriously. We see a lot of this kind of use case driven design where people imagine what the users are going to be doing and then they build that, and then it turns out that's not what the users wanted, or they wanted to do something else in addition. And I think that the semantic web stack is great for something like that. So I think some things we got right, some things not so much. On the good side, I think this is the usual list of things that we got right. And now, particularly with the labeled property graphs, we see this to be particularly true. So I want you to remember this list here on the left, because I'll come back to that in a little minute. Things that didn't necessarily work out so well, or that we still have to fix, is the whole idea of services and publishing. It didn't really turn out the way we imagined. Turns out it's kind of costs money to run Sparkle endpoints. And so there was we didn't understand that there needs to be a business model for all this. And in fact, when I realized that in the early 2000s, and I started going to conferences and say, what's your business model? I basically became kind of an outcast in the Semantic Web community. They basically told me that this is an academic conference, please go away. Sparkle, in my mind, is a success and failure, and I'll explain in a minute. And then the Semantic Web stack is often presented as what we call a layer cake, and the upper layers really never happened. And then my personal favorite, because I write a lot of code that makes use of RDF, we have no usable composite data types in RDF. Those are kind of the things, at least on my list, that didn't work out so well. But this is the list I want you to remember. This is all about sharing, and this is really the good stuff. So the things that need to be fixed, I'm not going to talk about all of these, but here on the right, sort of the non-technical things, like I said, business model, that we need to understand really what is the business model for knowledge. I'm not sure people yet understand what that is. And then, of course, people ask, is the Semantic Web Stack really something that's ready for the enterprise? I'm not entirely sure I understand what that means, but that's the question that people keep asking. And then I think that somehow the perception of the whole Semantic Web Stack is we should do something about that, because I get a lot of this. It's like, oh, it's so academic. Okay, fine. I don't think that's a negative thing. And people say, this RDF, I don't understand it. And I'm usually, well, I can explain this to a 7-year-old. I've tried and it worked. But then on the technical side, so let me talk about these three things a little bit. So simple schema language. I'm not entirely sure we have a simple schema language. So experience is that OWL is kind of difficult for users to understand. As a member of the team that builds an RDF triple store, I can tell you that no customer has ever asked for full support of OWL, ever. They ask for bits and pieces. And then, of course, we have Shackle. So we have at least 3 schema languages. And I kind of count R2RML as sort of a language that at least implies a schema. So maybe we have 4 schema languages. And there are a lot of people who are confused. So then Sparkle, I think the first version of Sparkle was just a disaster. And this is, I talked to I was not a member of the working group that drafted the original version, but this is what I told them, that they should have some good support for paths. And they really said, this is a literal quote from the response, paths are not the use case for graphs. I called them idiots after that, actually uglier word than that, but I won't repeat it here. Sparkle 1.1 is an improvement. At least there's some support for path traversal. We have federated queries, and now we can actually modify the data. What a nice thing. But really, Sparkle is missing path discovery. So you can traverse a graph, but afterwards you won't know how you got there. We have an idea in the Neptune team how to fix this, and I'll come back to that. And then there's also, this is what we have learned, is that regular software developers want absolutely nothing to do with Sparkle. I don't know why that is. I can't figure it out, but we have a fix for that too. And then there's this thing about composite data types. They're really difficult to, when you're writing code, they're really difficult to use in RDF. And actually, just this week, the ESWC conference is going on, and my colleague Olaf Hartig is there to talk about our proposal on how to fix that. So we have a thing that we, any day now, we'll publish the spec that we have written, where basically composite data types become literals in RDF. Okay. So that's the old stuff, that's the past. And now I look at sort of the modern knowledge graphs, and I think of them as kind of the new semantic web. There's a lot of adoption of graph technologies, including RDF. And in some ways, graph databases are now in the mainstream. They're not a sort of an esoteric curiosity anymore. We see a lot of use cases, and then of course we also see the introduction of non-symbolic or sub-symbolic AI techniques. And then of course, you know, I have to say it, but we also have the Gen AI stuff, and I'll talk a little bit about that in the future section. So, modern knowledge graphs tend to have a sort of a limited kind of scope or context. So usually it's the enterprise. So we talk about enterprise knowledge graphs. I see a lot of this where people use a knowledge graph as a sort of a substrate for integrating data, and in a way sort of, if not clean up the mess that exists, but at least hide it. And often, sometimes these systems are built as sort of closed systems, and I always think of that as kind of a mistake. You should really, even if you have a closed system in mind, you should build it in such a way that you leave open the option that there could be data coming in from somewhere else that you want to use. So this is now the old is the old semantic web, and new is the what we see now with knowledge graphs. So the scope has changed, like I said. The agents never happened really. So, but I would say that the actors in this new thing are really humans and cloud services or other software. But I come from a cloud provider, so I'll use the term cloud services. And of course, the source for all the content in this new stuff is really mostly enterprise data. And like I said, AI has gone from being not just symbolic, but also non-symbolic. So have we succeeded? 25 years on, have we succeeded? I think we have succeeded. First of all, everybody's talking about semantics now, without actually knowing what it means, but at least they use the word. And everybody wants some kind of a semantic layer. I don't think they know what that is either, but you know, hey. So this thing on the right here is 2 weeks ago, there was a big Gartner summit in London where they presented what they think are the top 10 trends in data. And this is what they said. This is a literal quote from the slide that Gartner CEO showed. It actually mentions RDF, OWL, and Sparkle, and knowledge graphs and ontologies. This is huge. This is, I think we're winning. It takes somebody like Gartner to say that, you know, but I think that we're really sort of hitting the mainstream now. So of course that sort of begs the question: is what comes next? And so, what is the future? If this is the slide that represented the transition from the old semantic web to the new one, so what goes in this future column? So of course it's Gen AI, and maybe now we can finally have the agents. We at least get decent conversational user interfaces. I am very much a skeptic when it comes to Gen AI. I don't think of it as magic like everyone else, and I've done this AI stuff long enough to have lived through the previous AI winter, which came about when there were promises that couldn't be kept and people were disappointed. And then there was this hangover and people kept telling that AI, oh, that's the thing that doesn't work. And I think we're now in a sort of an inflection point where we have this fantastic opportunity. When I say we, the AI community, we have this absolutely fantastic opportunity to really mess things up. Seriously. And I don't want to live through another AI winter. I'm too old for that. Maybe I'll just retire. What we need to do now is to basically manage the expectations of that and also figure out how can we use Gen AI with knowledge graphs. I see a lot of people starting to do that now, and thing I normally see is this, oh, the knowledge graph can kind of support the Gen AI. Graph RAG, people talk about that, and sort of focus the large language model to the relevant material. But I think it really should be the other way around, that Gen AI can support knowledge graph applications. Make the large language model generate graph queries, but have the answers come from the graph, because the graph represents trusted, curated knowledge. And I think in a way, sort of, we could imagine these that have been around in cognitive science for a long time, these sort of dual process models of cognition, and something that was popularized by this thinking fast and slow thing. So quick answers could come from the LLM, but the deliberate, careful answers could come from a knowledge graph. And I really hope that we're now finally getting the agents, because then the original semantic web vision could be absolutely complete. So, of course, we need standards. Standardization continues. RDF star was already mentioned. We're working on that. And then, of course, we have the labeled property graphs, which started out by having no standards. And now ISO has standardized a query language for graphs called GQL. And the real question is, what is the relationship between these two different kinds of graphs? So now here's the list. And labeled property graphs don't have any of that stuff. All the good stuff from the semantic web stack, it's not there. But labeled property graphs have other things. And so I'm really interested in kind of this sort of alignment or some kind of co-use of these technologies. But this sort of rift exists. There's two kinds of graphs and this chasm between them. And of course, I think the real difference is that labeled property graphs, they are a large data structure. But if you're using RDF and all the semantic web stack that way, you're kind of doing it wrong. So that's I think the real challenge here. And so we have been working on this project that we call OneGraph, where we're trying to provide cross-use of the different query languages over a single graph representation. And this turns out to be, I mean, when we started, we knew it was going to be really difficult, but it actually turned out to be even more difficult than that. And we're making progress. But what I said about Sparkle and how we could fix some of the things in Sparkle, so many triple store vendors have different kind of takes on this. Let's extend Sparkle to give it the features we want. Or, of course, we could wait for W3C to get their act together, but we don't have time for that. So our take on this is that, well, if there's something you can't do with Sparkle, maybe one of these other query languages will give you. If you really need to do path discovery, you can use OpenCipher for that, and you can run OpenCipher over RDF. And maybe that will take care of the developer problem as well. Who knows? So, in summary, some things worked, some things didn't work, but I think all in all, we're sort of in a net positive thing. You should really think of modern knowledge graphs as a manifestation of the semantic web. And so for the future, we have great expectations now for some of these emerging technologies, but also much confusion. And I guess we have time for questions. Don't all speak at once.
And please raise hand so we can give a microphone.
Also, I'm here all day, so you can come and talk to me later.
Thank you, Ora, for this nice retrospective and look in the future. So this question from Tim Berners-Lee, how the web is broken, how would you answer it today? How the web is broken today compared to back then?
The web itself, probably more broken now than then. I don't claim to fully understand anymore the dynamics of how the web works today. It seems that the conventional web has sort of been concentrated to be kind of the domain of just a few large companies. And the original vision of this completely decentralized distributed web, I don't know if that really is true anymore. But the thing I wanted to fix, I did fix. So, or we all fixed it. So, like I said, I think we're still net positive.
No.
We have someone there. Oh, okay.
Hi, thank you very much. I don't remember it very exactly, but I guess a few months ago, some graph vendors they published that they have released this ISO standard of graph.
GQL.
Yeah, exactly. Thank you. But when I took a quick glimpse of it, I didn't see a lot of mentioning of semantics. Maybe I'm wrong.
No.
What do you think about this new standard, ISO standard?
Well, having a standard is a really great thing because we haven't had standards on the property graph side of things at all. Now, GQL looks a lot like Cypher. Cypher had a big influence on GQL. Now we have a standardized query language. Of course, there are no implementations of that yet. And it's unclear exactly how those implementations will come about because GQL is not the same as Cypher. And actually, it's surprisingly difficult to find out how they differ, but they do differ. And then, of course, we still have this question of schema definition. So today, when you build an application using property graph, the schema is here. It's in your head, and then somehow you transfer some of that into your code. But the schema is implicit, it's hidden. There is work on schema languages for property graphs, but that's going to take a while. One proposal that I think looks pretty nice is this thing called PG schema. There was a paper in last year's SIGMOD about that, and it looks like a sort of a nice little, fairly elegant schema language. But we really need a schema language there. So this, of course, brings me back to the one graph idea. So can we use RDF schema languages for property graphs? That remains to be seen. There's all kinds of things we're discovering as we go about building the one graph thing. I actually did as an experiment, I did sort of a version of PG schema that could be used with RDF, where I then translated those things to Shackle and RDF schema, and I discovered all kinds of things that really make things very different. LPG data is not self-describing like RDF. And I don't think people even realize how big a difference that is. So it remains to be seen what happens on the property graph side. GQL is a good step. There's also now extensions to SQL to do the graph stuff. But I'm waiting for the schema languages.
Ora, thank you for the nice here. For the nice vision, retrospective and future, peeking into the future a bit. About the developers not wanting to do anything with Sparkle. Where are you taking this, or can you elaborate a little bit more on how can we seduce developers work with knowledge graphs?
Our answer is we'll give them another query language. They can continue using RDF, but here's another query language for you. That's our solution for it. And I'm not saying that that's the best possible solution for that, but the other options were, like I said, we wait for W3C, we wait for 5 years. We don't have time for that, or we extend Sparkle in some non-standard way, and we didn't want to do that. So we take OpenCipher and Gremlin actually later, and we tell people you can use those over RDF if you want.
So those are more developer-friendly
So it seems. So it seems. I don't know why, honestly. Well, Gremlin I understand. I like Gremlin a lot. Gremlin is more like a programming language.
Traverse.
Yeah, Gremlin actually is a Turing-complete programming language. But why is Cypher sort of palatable to developers, but Sparkle is not? Honestly, I don't understand that. But that's just what the data shows us and what customers are telling us. So that's our solution.
Thanks so much, Ora, for insightful introduction on the microphone too. I need the microphone.
Yes,
I can hear
yes.
you.
Okay, very good. Ora, thanks so much for insightful presentation. I'm just wondering at a meta level, because you're very deep to processes, looking at the history, for example, as web services evolved. They failed at the beginning as a W3C recommendation and took up then when industry got involved. And this is what I'm wondering, whether we don't need, or we would require more, as you said, like industry first approach, de facto standards and W3C to adopt and consider them quickly. Okay, so more industry involvement, more developer involvement, be the first one, the meta level, the processes, how to improve the cooperation of both. And the second is, do we forget about what we developed? I just recall the great XML stack, like Path, XPath, for example. Then we are going to talk about form generation. So X-forms were developed already way back. So this is a great declarative approach of modeling and potentially creating form interfaces. We just completely forgot about those with regards to semantic web and RDF or transformations. I'm just looking for the next stage of, we do have construct queries, but just have a definition of on-the-fly transforming RDF data. So this is what I'm saying. We developed a lot of great standards were developed, but we are not reconsidering them in light of RDF and semantic web cake. Thanks so much.
Okay, that's a lot of questions. So believe it or not, W3C was founded because there was this perception that the traditional standards organizations are too slow. Now there's a perception that W3C is too slow, that we need more speed. Now, RDF as a standard was not done the way standards normally are done. Usually standards represent a mature understanding of some technology that the industry now wants to they want some kind of a level playing field. RDF is not like that, or was not like that. But semantic web, the whole vision of the semantic web is that it's like a team sport. It doesn't make so much sense if only you play. Everybody has to play, or more folks have to play. And so we needed something for that. That's why RDF was done kind of too early, if you will. I don't like de facto standards because they tend to be things like, I call them standards defined by implementation. I like situations where I can have multiple implementations of the same specification. And maybe I just drank the W3C Kool-Aid for too long, but I do like standards. So that's that. And then the question of these other standards that you say we have forgotten. I'm not sure if we have forgotten them, but some of them just didn't become popular. And it's anybody's guess why something didn't become popular. When it comes to XML, there was, in the early days of drafting the RDF specification, I had a different idea about the syntax. It was actually based on S expressions, so like Lisp. And it was a very compact syntax. It would have been fine, but everybody else wanted XML. And I said, that's going to be a mistake. And then finally said, look, your proposal is technically better, but XML is politically better. And my mistake was to give up at that point. I apologize for that, because I think that adopting XML as a way of serializing RDF set us back quite a bit, because it resulted in a lot of confusion. And then people would say things like, well, what do I need RDF for? I can do this in just XML, and which represents sort of a gross misunderstanding of what we were doing. I think the only redeeming quality there was that it was possible to take legacy XML and run XSLT over it to turn it into the RDF XML, and then you had RDF. But things like XPath, XForms, sorry, I don't know. I don't know why those didn't take off. And then of course, now we have JSON, okay? But JSON is just XML done a little differently. It's no different.
Visit Ora in the break, and thank you again for a great presentation.